Okay, so let's see what we can do for today. The session is being recorded, so you can come back to it and watch it afterwards. I have already shared the guide material, the questions that we want to use as a means of revising for the examination. It will be appropriate that you get a copy for yourself right now and just go through them so that you can connect what we are going to do here with the question itself. It's very important for you to do that. So just within a minute, get the sample, the questions from the WhatsApp platform. Open and go through it quickly. You can, if you are watching, if you are joining the session through your phone, and use your laptop to do the downloading and then the reading. If you are also using your phone to join, I mean, yeah, you can also use the other one to do that. Okay, so I'm going to share my screen straight away so that we can look at the questions. So basically, we have to look at two things. The reason why we are looking at these two things is because for your examination, what you should expect, let me also take the opportunity to tell you the structure. I have already given some gist about it on the platform, but maybe I need to clarify further. You are going to have some set of objective test items. So a mixture of multiple choice and fill in the gap, which is going to constitute section A. Actually, you are to answer all questions for the whole of the examination. There's nothing like choose this from this as if the ones you will not choose doesn't matter in life. So you will answer everything. Everything is important. And the nature is what I'm explaining. The first set of questions, objective test questions, a mixture of multiple choice filling. I think it's a total of about 40 or 50 questions. I'm not sure, 40 or 50. And they are well within the scope. You have to read well. All the videos that you need to watch. These are things you need to do yourselves. No one can do them for you. If I watch the videos, you don't watch them. I can have a way to watch it for you. I can have a way to read the text for you. And these are the things you need to do to understand the concepts and to pass as well. One thing you have to note before I forget is the fact that the examination is engineered with the intention to assess your understanding, your practical understanding of the concepts. And therefore, they are going to be practical. If you can define something, if you can write the steps of doing something, then if you are given the task itself, you should be able to do it. So this is what I will not do. I will not ask you to define anything. I will not ask you to write the steps in doing anything. I will ask you to do the thing itself as we do it in practice. So you will program. And by that, you're supposed to have your gadgets ready, basically your laptop. On your laptop, make sure you have all the necessary, all the software that will require for this particular exam. And you know of the software already. They are the same software we have used in the class from the beginning of the semester till now. Microsoft Office, particularly Microsoft Access. Microsoft Access 2016 or later. 2016 or later. If you don't have it, get it before the exam date. At the exam hall, during the examination, we don't fix machines. We don't fix laptops. We don't fix software. Make sure you are prepared for the exam before you come. Don't ask anybody like, anyway, if you do ask, nobody will mind you. So that's it. Make sure you are ready hardware-wise, software-wise for the exam. Apart from the 40 or 50 objective test questions, you also have the privilege of doing hands-on. That's the reason why you are bringing your laptops and the fact that your laptop should be in shape for this programming exercise. You will program in SQL database and Python programming. The SQL database, our RDBMS will be accessed because that's what we used during the class. But the key focus will be on SQL syntax, SQL codes. The reason is that these are the technologies you need to prepare yourself for if you need to get the power and scale up in the industry and be a powerful person. The access graphical interface of clicking to create this blah, 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 and the whole of the access RDBMS is fit for some small business to about a medium-sized business that you may want to run by yourself. But if you have to be working with a big organization like Microsoft, like Amazon, like Google, or like any other, like Guinness, where you will have to be dealing with some very sizable data sets, it's most likely the application, the RDBMS they'll be using will not be accessed. No, it will never be accessed. It will be Postgres, it will be Oracle, it could be SQL Server from Microsoft. It could be any of these high-end interpretation of the SQL database. So that's where you need to have your focus. You shouldn't learn for the examination because the examination doesn't provide anything for you actually. It is the skill which will provide something for you. So the SQL programming part will skew for how you are able to do SQL programming, how you're able to write the codes. And they are not difficult stuff. They are just some broken English. It has a lot of logic. Follow the logic because you can't chew all the codes in the world. It's insane. But if you have the logic, you will know how the language flows. You will know the syntax of the language. And it's just like any other language that we learn. It has a structure. If you get a structure, you can speak it well. Okay, so that's about the database programming. And there will also be a section, programming section for Python, which will focus on basic Python data structures, data types, and data frame from pandas, and basic data frame manipulations. We have not been able to do much in the semester, but this will suffice. So that's about the nature of the examination. Any questions?
Yes, sir.
Yeah, go ahead.
Sir, please, with the videos use Python. Are we supposed to watch all the videos,
Please, can you
including
start
those?
your question again? I missed it, and try to speak out.
Okay, so with the questions, with the videos you sent to us regarding Python in management accounting, are we supposed to watch all those videos or just the
Oh,
part you
not
started with us?
necessarily.
Because
Not
you
necessarily.
haven't.
Not necessarily. Actually, some of them are relevant for what we are doing and therefore what you will be examined on. Others are to kind of tell you some of the things that you can use Python to do beyond what we have done in the semester. And most of the stuff you see they will be doing the next semester in management accounting. So it will just kind of expose you, enlighten you, but you will not be examined to that extent. You will be examined to the extent of what I just described. Basic data structures, string, lists, dictionary, the pandas package, and the data frame function in that package, and how it is able to convert dictionary into a data frame which has a lot of capabilities of manipulating data to extract meaning, insightful meaning from the data sets. Basically, this is what we've been able to do in the semester. So anything beyond this will be something that you want to explore, but I will not examine you on it. But that exploration can also reinforce your understanding of these basic stuff we are doing. Is that okay?
Yes, sir.
Okay. So let's see. It's very likely we will not be able to. When are you writing your exam? Let me get that information.
On the 6th,
On the 6th. 6th is when?
Tuesday.
This coming Tuesday.
Yes, please.
Okay, no problem. So let's see what we can do. So this kind of example, do you see my screen now?
Yes, please.
Yeah, this kind of example is like it's going to test you how you create variables or data objects in Python to reflect the way we keep data in everyday life. For example, this is a list of students like yourselves, a list of your scores in 3 courses: maths, physics, and chemistry. It's natural to keep data this way, and in most cases, we write data this way, especially if it is some small data set. We write it this way. So in Jupyter Notebook, you are supposed to be able to create a variable called students like this, and then just assign that variable to a list of students as you have. It can be many than what I have. This is just for demonstration purposes. Then a list to store the scores for mathematics. So I think they took 4 tests in mathematics, 4 tests in physics, and 4 tests in chemistry for the semester. You have to be able to create variables for all of these list items. And that's very basic stuff, which we have demonstrated. The main thing we want to add to that is when I have, for example, math scores created in Python, what are some of the manipulations I can do? We have looked at some of them, which is basically how you update the list. But you can also perform some mathematical manipulations on the list. For example, you might want to get the maximum number in the list. You might probably, because they are numbers, you might probably want to also get a minimum. You might want to calculate the sum. You might want to calculate the average. These are all some of the calculations you may want to do. Yeah, these are some of the basic mathematics you can do. We'll also look at how you can convert this current data form in variables, list variables. So we have variable called students storing a list of students, variable called math scores storing a list of math scores, variable called physics scores storing a list of physics scores, and so on and so forth. We will also want to see a more appropriate way of storing such a data structure. Well, this is one of the ways you can store it, but there can be a better way. For example, if you look at this, well, you can also convert this to a dictionary. And if you look at it well, we are also taking this opportunity to look at some a little bit complicated structures. I don't want to use the word complicated, as if the word complicated is a bad word. Complicated because I don't have the right word to use, but it's not complicated that you can't do it. If you look at this, you will just see that I'll demonstrate it. If you just see that if you want to convert this to a dictionary, where the key is the student, usually that's what you want to do. Okay, for every student, what you want to store the corresponding math scores, physics score, chemistry score. So now we start from the student. Okay, student Amma, we assign you your math score, your physics score, your chemistry score. Student Kofi, the same thing. Akuya, Abba, the same thing. Currently, this is not how you see it. So that will be the nature of the dictionary. And you will see that that dictionary will be a dictionary of dictionaries. So there will be an outer dictionary and some inner dictionary. It is not complex. When we implement it, you will see that, oh, okay, based on the way the data appears, this is how it has to be structured into a dictionary. In some other cases, the dictionary can be just like maybe AMA, and if we didn't have categories in the subjects, so let's say it is just one subject, then that one, it will be AMA, and then AMA's list of scores. Kofi and Kofi's list of scores. We don't have categories in courses. That will be a little bit straightforward. That will be like a dictionary of lists items. But this one will be a dictionary of dictionary items also. When we implement it, you will see it. Then from the dictionary, well, we have also learned how we can do dictionary operations. Like a dictionary is not indexed, ordered, like lists. List is indexed, ordered. What that means is that list has an inherent index number. Every list item has an inherent index number. So the student's list, Amma here has an index number. It is inherent, you don't need to see it, but Python assigns it if you do this code. It assigns the index numbers from 0. So the first person is 0, 1, 2, 3, in that order. Dictionary doesn't have that indexed order built into it. I just know that there is some other type of dictionary which has an order, but the basic dictionary data structures you have in Python, it's not indexed ordered. It is key ordered, right? I mean, it is not ordered as in you have position. So this is your 0 position, this is your 1. It doesn't have that order. So what that means is that unlike lists, where we can use the index position to access that element, we cannot use that same technique in dictionary because dictionary items don't have index numbers. So we use the keys as the means of accessing the values in the dictionary. So we access values through the keys. You have to understand that. So we have done some of those operations where, for example, we can do AMA, maybe, yes, we can find AMA's scores or the sum of her scores from the key, which is the AMA itself. We'll see it in Python and you'll understand it more. So we have our dictionary created. We can do some manipulations, data manipulations using the dictionary data structure, but it is not rich. That data structure is not rich in methods, in mechanisms that can help us analyze data into a deep sense. It doesn't have it. Dictionary doesn't have it. So we always kind of do these things, transitioning into a higher level of data structure, which provides us complex and powerful structures, methods, functions to manipulate data. And that's the pandas data frame. So we also look at how we convert this. So first is, variables, basically list variables, how we do manipulations on them, converting this into a dictionary, how you do some manipulations on the dictionary, converting the dictionary into a data frame, how we do some manipulations on the data frame. So that's where we can take ourselves to as far as expectations in the examinations are concerned for Python. And for the database, we have done a full implementation of a system, if not a full, yeah, it's almost a full system, social club system, where we have members entity, we have dues entity, we have programs entity, we have occupation entity. We have looked at the relationships, possible relationships between these entities. And then before even the relationships, we looked at the attributes, the appropriate attributes for each of the entities. And we also know of the appropriate data types to assign to each such attributes. And then we have learned about how to assess the relationship between entities through that system modeling, which provides us with beautiful skills, very good skills to look at other systems in terms of modeling them into a database. So now we are going to look at a more business-like setting. It doesn't mean what we look like is not a business. I mean, social club is a business. You can be the accountant or the database manager of the club, and that's also business. But we want to look at it from a traditional business, more from transaction cycles, sales, inventories, products, customers, those kind of things. So this is it. I'm just giving an overview of the database. When I finish with the overview stuff, then we will start them from the top again. So this is it. Normally when most businesses, let me put it that way, most businesses are structured such that they deal in physical products. So they buy the products. In the first place, they have some products they deal in. They buy and sell, or they produce and sell. And they are supposed to have a listing. If you are doing things right, you're supposed to have a listing. And maybe in a flat file system, the listing will be something you can find on a sheet of paper or in a word processor on some computer. But in terms of relational database, you're supposed to have it in a database. In other words, you're supposed to have that sub-database for all the products we deal in. If the product updates, we go and update that sub-database of the products we deal in. All right. So we need to get a table. In other words, we need to get an entity called product or products, which does this job of storing all the products we're dealing. And at this point, as accounting students, you can even think of some of the features that you want to pick off the product to store as the product database. So things like product ID, product name, product description. Sometimes you can have category if you have subcategories within the product. So maybe you are dealing in electronics and maybe you have laptops, you have desktops, you have pen drives. So you might want to show these categories. So you can have a category attributes, you can have selling price. The basic idea is that we're supposed to have a standing data on the things we sell with the following attributes of those things: the product ID, the product name, description, category, selling price. Yeah. So when we have that, what happens? The next, part of the system is that we have to go and buy these items that we deal in them. Yeah, we have a database, so we can go and print, oh, okay, these are the things. Oh, okay, this is the product ID. Okay, how many different product IDs do we have? Which is going to represent the different kinds of products that we deal in. Or maybe 10 different kinds. So we have 10 different products. And what is their product names? What are their product names? So you can know the different product names from that database. You can know their descriptions. You can know each product type, which is represented by the product ID, its selling price. So if the product ID matches, okay, the matching product name is, let's say, the matching product category is pen drive. Then you can find the selling price for that particular pen drive. You can do a whole lot of calculations inside the SQL database itself. Yeah, when we have the listing of all the products, usually we also have a warehouse where we buy these things in different quantities and stock them. So you have the inventory. So physically the inventory is there and you're supposed to have a database which reflects the physical implementation. So you have some warehouse somewhere. Yeah, we're supposed to also have the web, the store, the warehouse also in a database form. Also in data form, the data should kind of be telling us what is happening with the physical things. So we can read what is happening physically from the data. And that is data science, data analytics, data mining, whatever you want to call it. So that will be the inventory table. And at this point, as accounting students, business students, you can even imagine some of the attributes that you will have to keep here. What happens at the inventory section of the organization? We get in the inventory. So when we are getting in the inventory, even though it's going to the warehouse physically, it also has to get to the database, if you like, data-wise. So we will have inventory ID, which will represent any time that we are entering a batch of inventory. It can be one, it can be more, but typically Inventory will not be one item, it will be a batch, a set, or a chunk of some items of inventory. So let's say at this point in time, we have some invoice and some other documentation which evidences some inventories that we have received. So we go to the inventory database. As we are entering that inventory, we invoke an ID for that transaction in the inventory table. So that will be the inventory ID. What again will we record in the inventory table? We will have to indicate the product which is coming in. So that will pull from the product database. So we'll have a foreign key, which is a copy of the primary key of the product table inside the inventory, which is going to match the product we are sending to the warehouse to the product list. So we'll have product ID inside the inventory table. We will also want to know which supplier these items of inventory is coming from. So that will also be pulled from the supplier table. So that will be a foreign key called supplier ID, which is a copy of the primary key of the supplier table. Then we will want to know, okay, well, these are the items represented by the product ID. This is the supplier represented by the supplier ID. This is the, let's say, the transaction date or the purchase date. You need to get that information. Date is very important for you to check even the inventory management, the efficiency with which things are. So purchase date will be there in the inventory table. You will also want to record the quantity of that product represented by the product ID, which is coming into the inventory. So that can be captured as quantity. And then you will also want to indicate the purchase price per unit, which will help you calculate the inventory amount for inventory management purposes. Apart from the purchase price, what again would we want to put there? It reflects the way we manage the inventory system, which you know very much from your accounting background. Okay, so that will be the inventory. And you can directly see the connection between the products table and the inventory table. When we are getting things into the warehouse, which is represented by inventory, those things are some products which we have listed in the products table. So that's how they link. And then we come to the sales table. When we have product lists, we use the product list to go and buy. When the items come into the warehouse, we set up an inventory account for it, which is the inventory table in this case. So we have our inventory. For what reason do we have the inventory? To sell them. Okay, so you're supposed to, as the selling is physically happening, we're supposed to have records which is tracking the sales which are physically happening. And that is the sales sub-database, or if you like, the sales entity, and therefore the sales table. So every sale transaction that happens will be captured in the sales ID. So the sales ID can track how many number of sales, or the number of sales you have made in any particular period. Each individual sale ID. Then we will also want to track inside the sales table the sales dates. The customer who is buying who is making the sale, who is buying the things, which means we should have a standing sub-database for the customers. So inside the sales table, the customer who is doing the buying will be represented by a foreign key called customer ID, which is a copy of the primary key of the customer table. So we know the customer who is selling. We will also want to know the product that we are selling. So per each sales transaction, we're supposed to know the dates of the transaction, the customer buying the items, and the items that we are selling, the quantity that we are selling, and the selling price. So you can see that we have selling price in the sales table, and we also have selling price in the product table. And the question is, why do we have the two? I actually put them two there for practical reasons to reflect how the things flow naturally. In some other designs, I know you will be reading on the web, you can have the design a little bit different from this, but I did it this way just around how naturally the thing flows. The selling price that we have in the product table will be the historical selling price. Sometimes we can have a selling price and it might change at a point of sale. Basically because maybe we have to give some discounts whatsoever, right? That can also even help us to know, okay, what was the standard selling price, or what was the selling price as it used to be, and what was the actual selling price, for us to do some variances between those kind of things. If you think you are in a system where everything is stable, there's never going to be any fluctuation in an initial selling price and an actual selling price at the grounds of sale, then you might decide to probably take the selling price from one of them, one of the tables. I did it this way because, well, in the product table, the product also has that attribute of selling price. We can put it there. But when we are also selling at the point of selling, the selling price is also there. And sometimes the selling price at the point of selling may be different from the selling price as we put in the table at the time that we were capturing them. So when you do it this way, I think it's okay. It also means that when at the point of selling, you have to use, once you have set the table like this, having the selling price attributes also in the sales table, you will actually be capturing the selling price through the sales table, which will be the current selling price. Yeah, that's what I was thinking about it. If you think a little bit slightly from that, that's okay. So try to get this logic. You are accounting students, these are the things you study. If you don't understand them well now, that's not a problem, because you can understand them anytime you want to understand them. Then we will want to know the total amount, which is a product of the selling price and the quantity. So this is how we might want to set up. In fact, this is how the selling happens to a very large extent. These are the things that happen in the selling process. There's a sale transaction, individual sales transaction. It happened at a particular date. There is someone buying, and there are specific products he's buying. He's buying a certain quantity of it at a certain selling price, and we have the total amount that he has bought. We capture all of these attributes into the sales table. Then suppliers, they will directly link with the products table. So suppliers table will be the standing data sub-database for all the people that we buy from. So supplier ID for each individual supplier, supplier name, contact phone number, and email. Because you will need them Just imagine you want to buy some items and you don't have any standing sub-database for your suppliers, and then you don't even know which person to call. Oh, I have to call this person. Oh, I've forgotten the name. Then you have to be trying to call another person. It's a waste of time. Anybody whose life is like that will never make any progress. So we do these things to make us do the things right, get them right, and move forward. So we have the suppliers database. And of course, I think there's one sub-database or table missing. That will be, yeah, it is already here. That's the customers table. So this is an overview of the sales processing system. If you like, the whole system of a retailing business. Products we sell, products in inventory, selling them. You have our suppliers. In the inventory table, you can track the quantity of items that are outstanding or the balances on them. In the sales table, you can track your sales for each individual item, even for each customer. Exactly. You can do a lot of things with this kind of setup. So this is the basic structure for a merchandising business, buying and selling business, if you want to track what is happening. We're supposed to be able to draw a professional, what do we call it? ERD, entity relationship diagram for this, which also requires that we are supposed to be able to know the relationships between each of the entities, because the entity relationship diagram will require us to do those communications between the tables specifying the cardinalities, whether it is one-to-one, one-to-many, or many-to-many, and how we model those kind of relationships physically in the database implementation, in this case, using Access. So that's it about the database in a broader overview. Any questions? Okay, no questions. So silence means no question.
So, sir, with something like this, are we to go by the SQL, or you can go by the straightforward table creation? Like, I mean, you just
Even though my stress and my encouragement is that you have to focus more on the SQL syntaxes, because that's the learning that you really need to do, and you shouldn't learn for exam, actually. We'll use exam to test whether you have been able to do something. It's just a formality. But when you are really learning for what is out there, to solve those problems there, so that you'll be attractive to people, companies which need problem solvers, you need to do the SQL one. But in this particular case, you can create, for example, if you are asked to create a database and do some manipulations, you can create them with a click, with a clicking, because we are using Access. You can also probably want to hone your SQL skills. So even though you can create them by clicking, you want to learn how to do the same thing in the SQL editor, and therefore you will create them with a SQL syntax. Programming is a language, and it's just like any other language. The more you speak it, the more you become fluent. So the more you give yourself the opportunity to learn what you have to learn, the more you become better in that thing. So that's just a word of an advice. Okay, so when we have it created,
Hello, sir.
we are supposed to also learn some.
Hello, sir.
Yes, please go ahead with your question.
Please, with the suppliers, should we separate the contact information from the suppliers?
No, I
Hello.
think the other time I tried to explain that kind of thing. If, for example, in the suppliers database, we have supplier, we have contact phone number. When we do it like this, in order to reduce redundancy, which is the main thing we want to prevent, we will not store multiple values under this column. So even though we have contact phone number, we can't do something like 02465126555/050. No. When you do that, then that is a violation and that will throw in a lot of redundancy. So when we do it like this, we have not broken any rules if we store only one, because we have adhered to the atomicity principle. Only one
Okay.
phone number. Are you okay?
Yes, please.
Yeah, but if you have the interest of storing all the multiple contact details, maybe even if they have 5 phone numbers, you want to store all of them, then you might want to create a contact table which will store all of these details, and then you link it to the supplier table, or whichever table that it applies to, it's linkable to. Is that okay?
Yes, please.
Okay. Any other question? Otherwise, let's see what we can do.
No, sir.
Yeah, let's see what we can do. But that is around how you will be examined. So you have to learn well. The main thing that is important is you understanding the logic of the system. These things are systems. Look at the database. It's the whole of almost the transaction cycle, the whole of that system, from point of purchasing the inventory to the point of its exiting. Everything that happens in between, you are modeling and tracking it, tracking the data beneath it, the data underlying all of these physical happenings, so that you can use the data to understand how things are happening and make the changes necessary. So that's the way it works. For you to understand these things and do well in them, you always need to develop that instinct of understanding how things work. How things work. It's not the theory. It's not knowing how some beautiful words are combined to provide some sophisticated definition. No. The real knowledge is, how do things work? What is the structure of their mechanisms, of their workings? How do they work? So this is how it works. When we are selling, we buy the products, we put them somewhere, people come and buy. This is how it happens, and we want to model and track the data as the things are happening. It generates data. We want to track the data and use the data to understand what is actually happening. You need to understand it this way. If you want to chew this, it will be a big task for you. I don't think you can even do it. And if you don't understand how things work out, you can't understand them. You can't learn them. You can only fake learning them. Okay, so that's just by the way, just to help you revise around these stuff. Let's go to another interface where we begin something hands-on. Okay, so let's play with the data that is in the, what do we call it? It's in the tutorial question. Okay, can you see my screen? It's a blank notebook. Confirm if you
Yes,
can see.
yes, sir.
Yes.
Yes, sir.
So you can see that in the
Yes, sir.
Yes, sir,
tutorial
we can
question,
see.
we have something like students. Please, I I said you should download it so that you can reference it and then follow along. So we have students. And the students are a list of some students, Amma, Kofi, Akuya, and Abba. So this is how we do them. So we give the variable name here, students, and we said the variable name should be descriptive. You can't say X and then you are storing into that X a list of some names. Later, you yourself will be struggling with X is what. But if you had stored students, it's self-explanatory. And this is the list notation. And I think there is a function called lists, which you can also use. I have forgotten the syntax, but you can search for it right now. But let me just try and see. Lists is a function. So every function it has this opening, closing parenthesis. Yeah, I think the function's name is list. And then it will take, let's say, let me do, for example, 1, 2, comma separated elements. Usually that's how the structure is like. If this is correct, it's supposed to create a list of students numbered 1 to 3. If it is not, it will throw the error and explain to us what the error means. List expected at most 1 argument and got 4. Okay, so this is what it means. The structure is not exactly like this. Even when you want to use the list function, you still need to use the bracket. That's why it doesn't make sense to actually use this. So when I put the comma separated stuff in that list notation, which is the square bracket, I think that will be fine. So this is another way of creating a list using the list function. But I think this is quicker. See, it's the same thing if I do students, and then if I had ignored the list keyword and the parenthesis, but just go ahead with this and said 1, 1, 2, 3. It will be the same results. But at least we know that the list function is also there. So we have the lists of not numbers, but some individual students, and it is their name, so it is string. So when we are typing string, we put it in quotation, Amma, then comma, another quotation. What was the other name? Please, you can engage. What's the other name? Kofi. At this time, you can look at the list and be providing me with the name so that we can move faster. What is the next name?
Kofi is the next name.
After Kofi is what?
Abba.
Equia.
Akuya, good.
That's all.
And then the next one,
Abba.
that's the end, right?
Yes.
Okay, so this is how we create a variable. And it's just by giving a descriptive name and assigning the value to that name. That's variable creation. But this particular variable is a list variable because we have created a list of names. And this is how we can create a list using the list function. So list, open brackets, and then you put the list items in square brackets separated by commas. Or you can just decide to use the the list literal, which is the square bracket separated, containing elements separated by commas. We use the same mechanism to create the rest of the lists is the same way. So now I'm going to complete the rest of the list as such. So you see we have math scores, and it's a data which is like, okay, we have 4 students, and then we have for each student, their scores for math, physics, and chemistry. And each of the courses, they did 4 tests. No, they didn't do 4 tests. For each of the students. So it's like Ama's math score is 85. So Ama is the first entry in the student. The first entry in the math score is for Ama. The first entry in the physics score is for Ama. The first entry in the chemistry score is for Ama. Kofi is the second person in the students list. The second entry in the math score is for Kofi. The second entry in the physics score is for Kofi. The second entry in the chemistry score is for Kofi. So that's how it flows. So this is some data which has been captured this way. And readily you can figure out that, well, we have captured it this way, but this is not the most intelligent way of capturing such a structure. If you look at it, the person wants to communicate like, okay, I have a list of my students, and then I want to show how each student is scoring under each of these 3 topics. Usually, you want to capture this in some tabular way. But this is one way Python can help you capture it, not too intelligently, but at least it's still some way of capturing it. Even with this basic way of capturing it, we still can find some information. We still can do some data mining. We still can do some insight extraction. For example, we might want to find, apart from the fact that we can add to each of the lists, we can add to the student lists if the need be. We can add to each of the other lists, which we have explored some time back. Apart from those manipulations, we can also find the sum of the math scores. Sometimes we do that. We want to find a total. Well, these are the separate scores we did for math. What is the total? Sometimes it can help you to know, okay, people are doing well in maths. Maybe the sum of the math scores is bigger than all of them than the rest. It's a statistic that can tell you something. If you want to do that, there are basic functions in Python. In fact, we have already been using some of them because they are so fundamental that anytime you're programming, you use them. Something like the print function. Print. You want to show the item on screen. We also, what other function have you? The other time we talked about the type function. So I can call the type function, which is just to say type, and it's a function. So open, closing parenthesis. I want to check the type of math score. So I pass the math score objects into the type function. And make sure you type it exactly as you stored that object. It is math underscore scores. Okay. So let's see, name math underscore scores is not defined. Okay, I think I have not run this cell. Okay, let me run the cell. When I copied and pasted these objects here, the math scores, physics scores, chemistry scores, I didn't run the cell, so it is not in memory. Now that I've run it, if I run this one, it should work. It tells you the object type is lists. And if you check all of them, it will tell you it is lists because we have created lists. And of course, so that is type. Of course, we could have also said Well, when you're using IPython, which stands for Interactive Python, in Notebook, that implementation is there automatically. There are certain things that happen automatically for you, but in actual programming, if we wanted to see the list, the type of the object on screen, we should have passed the whole code inside the print function. So that's what the print function does. Print, open parenthesis, closing parenthesis. Inside the parenthesis, what you want to show on screen. In this case, you want to show on screen the type of mark score. It will bring you that it is list. It only adds this keyword class. This is some advanced concepts in Python programming. When you grow, you will get it. In the meantime, let's make it stay where it is. So at least it is still list. So the homework I'll give to you is that today, this evening, or as part of your revision, just open ChatGPT and type something like this: Python's built-in, or you can say basic functions or built-in functions. I think they'll return basically equal results. Basic functions. I'm doing so currently in my ChatGPT and see the results. I'll just read a few things for you to see. And that's what you have to also do. And then when you do it in ChatGPT, in addition to getting the names and the names of the functions, you get to know the syntax, the structure of those functions. And you also get the advantage to see them in simple use cases. This is how you can use to get blah, blah. And that's how you learn the language. That's how you learn the language. So this is the results. Python provides several basic functions as part of its core language and its standard library for performing a wide variety of tasks. These functions are essential for everyday programming and data manipulation. Below is an overview of some of the most commonly used basic functions in Python. Prints. So it titles it input and output, and then one, prints, open closing parenthesis, outputs data to the console. And then it gives you the syntax, print into brackets, hello world in quotation, for example. Then we also have input function. The input function takes an input from the user. So you can do a program where if you run it, there's a cursor blinking that the person who is running the program inputs some data. And then your coding feeds on that data to calculate some things and return the value. Next semester, when we are doing management accounting, where we get the means to implement some of these principles in some other subject areas like management accounting, we will learn about functions. You can see how we do some of these things. So the input function, you can learn basically about it. Then we have the int function. Remember, we had the int data type, which is int, int. And here we have int open closing parenthesis. So int function. It converts a number, which is not a number. So this is something that looks like a number or a digit which is stored as a string. It can convert it back to an integer. It can convert a decimal number also to an integer. So that's what the int function does. Then we have the float function. It also converts stuff into floats. Then we have the str function, which also converts something else to, for example, you can convert 10, which is numeric, to 10, which is string. We also have some mathematical or statistical functions like ABS. It's for absolute. We have round, if you want to round a decimal or a float number. We also have checking elements in a sequence, the number of elements in a sequence, like the len function, len. So go home and do all of these things. It will help you. So now we can check that, okay, what is the number of elements in any of the lists? For example, we can do len students. So we want to check the list, the length of the list. Normally, you see, this one is 4 data points or so, so your eyes can readily see, okay. But we are doing this for a demonstration on the real things. We are just demonstrating what really happens. What really happens is complex that probably we will not be able to finish it here. That's why we are representing it this way. In real terms, you will be dealing with some large data sets such that you can use your eye to know the number of elements. In this case, the number of students. Let's say I'm dealing with your records level. Let's say it's combined record level 200. Become accountant. You are 400 plus. Code people are joining. Let's say finance people are also part. And you have that list here in our face. You will always want to check, okay, what is the individual entries and therefore what is the number of students? And that's where the len function becomes useful. So when I run len, it says 4. So if you were doing that for that large data set, it will accurately get you the number of students by passing that list into the len function. All right, so the rest is for you to explore. So that's how we create functions. And let's see some of the manipulations that we can do on the function. For example, if you want to find the sum of the math scores, there are functions like that. I think I should have seen it. Mathematical function. So let's say sum. So we have the sum function. So I can just say sum math, and of course, sum is a calculation. So you can't do sum students. You can't sum Amma and Kofi and Akua. It doesn't make sense to sum them. You can actually count them, but you can't sum them. They are two different languages, summing people and counting people. We sum numbers, so sum math underscore scores. And it says it's a total of 345. But usually, calculation you perform, you will need it in your subsequent coding. And when that is the case, we always store some of these intermediate calculations into variables so we can call the variables later. So instead of doing sum math into bracket, sum into brackets math underscore scores, you might want to give it a variable name. So let's say, you can say probably sum underscore, let's say math, sum underscore math equals this. Okay, so when we run it, it will store it in the object called sum math. So if you want to show the content, we can call sum math in addition to this code. So sum underscore math. And when we run it, will tell us the same thing, 345. Which means that anytime we want to use the sum of the mathematics score, we just need to call sum underscore math. Sorry, and that value will be available. How about if you want to find the average? I think in scoring, that is a very useful statistic. It's almost used every time. You want to find the average score, the representative score. And I think from the average score, you can even find your standard deviations and stuff. They all revolve around the mean. The average is also called the mean. From your basic quantitative methods, I think you should know about this. So let's see. Sometimes it is good for you to experiment based on the logic you have picked so far. You can hit against the wall, but that's the beauty of this kind of learning. So now I know that when I do sum and pass the objects into the sum function, it returns the sum of it. So maybe I want to try try and see, okay, does it go that way? So maybe I will do mean and say math scores. So we have to read what the problem is. It says name error. Name mean is not defined. What this means is that it doesn't understand the mean here to be a function, to be an inbuilt function. And if it is your defined function, there is nothing like that yet in the computer's memory because you haven't defined any function like that by yourself. Probably you can define a function that you call mean. That is a user-defined function, which probably works on these things to store their mean. If that is there, it will use it to run. But there is no inbuilt function called mean like this. And there are some other ways that you can also work things out. For example, this way I did it, for example, sum into bracket math score. We are just using that sum. And then we are passing the objects into the sum function. There's another structure where the object like this, what do we call it? Math scores objects, this list objects. Some objects automatically have methods built on them. Once you create them as that object, they inherit some methods. They inherit some functions you can employ on them. And a function which is inherited by an object automatically, that is what we call, method. There's no difference between a method and an object except by this explanation. So you can also use it by the method way. In other words, if the object math underscore scores, which is a list object. So if generally lists objects have the method of calculating mean, then it will be coded as this: math scores dots. The methods are always applied as a dot notation. Math scores dots mean, like this. If it has that method applicable to it. If it doesn't have it, it will tell you that object doesn't have this method. So let's read it. It says attribute error. List object has no attributes mean. No attribute or no method mean. Okay, so what it is that lists don't have a way to calculate their mean directly as I'm trying to do. So if we want to calculate the mean of list items like this, we usually use NumPy. NumPy is a dedicated package for mathematical computations, and it's so deep to any form of mathematics, including this basic stuff we want to do. So in that case, what I will do is that I will have to restore these math scores as NumPy array. It's also a list of items, but NumPy has its own structure of storing list items, which is not exactly the inbuilt lists objects. And when you store the lists as NumPy array, or NumPy, if you like, NumPy lists, it's not professionally called so, but just for you to understand, NumPy lists, or a list item stored in NumPy format, which is called NumPy array. Then you can have the opportunity of doing these mean and some other calculations as well on them. Let's experiment. So I'm going to do NP. So this is some introductory way of introducing to you that package called NumPy. What it means is that it's an advanced package, so it's not inbuilt. It doesn't come automatically when you open your Python. So it means you need to import it. So this is how we import it. Import NumPy as NP. if you look at the project you are doing and you will require additional packages, you can import all of them. Usually you do so at the top of your notebook. All applicable packages, you import all of them and then you start your project. That is the convention, but you can also be importing the packages as and when you think that, okay, I need this. For example, in this case, now that I need NumPy, I can just import only NumPy. But if I think, oh, the part of the work will also require pandas, I can import them all together. Import pandas as NP, as PD, sorry. And when I run, if you type everything correctly, it should run clean without any errors. So now let's see how we do NumPy array. The same way we did the list, we could have created the same list as NumPy array. So to do that is to say, so let me just prefix this with NP, just for us to say, okay, I am recreating this maths course into a NumPy array form so that we can see the difference. So NP underscore math underscore scores. In other words, NumPy version of that same list. And let me store it as NP. Because we imported NumPy as NP, we always have to, when we are using NumPy, we have to do NP. So NP dot array. So this is the syntax. This is how, if you want to create a NumPy array, this is how you speak that language. This is how Python knows the structure of the statement. NumPy array is a function. So into brackets, then lists item. So let me copy that list item into brackets. So the only thing which is different here is the array function. NumPy.array, that's the function. And then you put inside it the list of the items like this. And run. So now we have NP math score. So all the stuff that we couldn't do when we have stored it as the basic list with NumPy list, so to speak, or NumPy array, I can do the mean. For example, if I do NP underscore math underscore scores dot mean. Because this one is a NumPy array, NumPy array automatically inherits the objects, sorry, this method called mean. So when I run, it tells me the mean of this range of scores is 86.25. In basic Python lists, the way you can go around this is to probably, because you can't calculate direct mean, but you can calculate sum, because we did the sum, which is 3, 4, 5. After calculating the sum, you can calculate the count through the len function, and then you do average or mean as sum divided by the count. So let's try that one. We have the sum. We said we stored it as sum mark. Let me call it for us to be sure. Sum mark. Yes, so that is the sum of the math score. So now let's create a count mark, which is the count, the number of items in the mark list. So count mark. And I'm storing count mark as the length of that list, so len function. So this is how you have to engage with the program. We are learning pieces of things, but it's about how all the pieces of things play together for you to do some bigger thing. Now we are calculating the counts of the elements in the math list. And we just realized, oh, the len function can help us get it. So len, and then I do math underscore scores. We have even calculated it, but I didn't store it as an object. So that will give us, let me call it for you to see. So we have count math. Name math score. Okay, this one is scores. So you have to always make sure you spell it the same way as you typed it previously. So it's 4. So now when I do mean math equals sum math divided by count math. It should give you the same results as when we use the NumPy array and therefore the method mean. So let me run this code. Okay, it means everything is correct. So let's call mean math, and it should give you the same value as the one returned by the NumPy array, mean math, 86.25. 36.25. So these are some of the mathematics you can do, the limitations of the basic list, how NumPy can come in to help. So now let's see. If I do math underscore scores dot median, will it work? Okay, this is the list. So let me do it on the NumPy array. So NP underscore the same thing. I think that's how I did it. Let me check. Yeah. So now let's see. NumPy object has no attributes. Okay, I think the median was wrongly spelled. It doesn't have median attributes. Let me see if it has mode. Yeah, so you can use ChatGPT to check, confirm whether NumPy arrays have methods, mode, or mean. And if they don't have, how you can go around to do that calculation. I will not get a time to check this. This is your assignment to check it out. We can check it just right here. Go and do it, the checking. Okay, so we have seen lists. Some of the mathematics we can even do on lists. Storing lists, items as lists, not too intelligent, especially if the data structure is a bit complex. Now let's see how we can improve this data structure. We can see we have some list of students and their scores in some courses. Maybe dictionary will be a better way than lists. And also data frame will be a better way than dictionary. So we are going to transition through them. So now let's see dictionary. Okay, so how we convert the same thing to dictionary? So now let me say student scores as the object name.
Officer. No, no official. What official? Well, to make it unique.
So with student scores as the object name, if you are creating a dictionary, we know that the dictionary notation is curly braces. Yeah, so we create a dictionary like this. I will not create a horizontal dictionary statement. that is not nice. So inside the curly braces, when you press enter, IPython automatically understands that you want to create the dictionary items in a vertical list. That makes it more readable to the human eye. So the list we want to create it such that for every student, we want to know your corresponding course in the 3 courses. So we kind of using the students to do that. So students, your scores in all the 3 courses. We can create it like this. So in this dictionary, we will have the students. So the first item will be AMA. And this AMA, the matching values is the course and the score of the course. So you will see that what we have to store is our 2 things, the subjects and the corresponding score. For AMA, it will be the subjects and the corresponding score. So it will be math, corresponding score of math, physics, corresponding score of physics, chemistry, corresponding score of chemistry. So that will mean that this will have to be a dictionary of the subjects score pair for each student. So for AMA, his scores are a pair of a subject and the score for the subject. So we'll have this, which is the subject math, pairing with the score, which is 85. 85. So that's the first key value pair, the first course score pair. The next one, so comma, then we have physics, with a score of, so all the first entries are for AMA, score of 88. Comma, the next key value pair is chemistry with a paired value of a paired score of 90. Yes. So we have come to the first, we are done with the first item, which is this. Which item itself also has a dictionary inside it. So this is some nested dictionary, an outer dictionary, which has an inner dictionary within it. If you pay attention, you will get the logic of this structure. It reflects the nature of the data sets. So the next one is Kofi. Who also has the same structure. So we can copy this one and modify them to be easy. Okay, so for Kofi, math score is, please get me the scores. What is the math score for Kofi? Let's be interactive, please. Math score for Kofi. Kofi is the second person. It's 92.
Yes.
92. What is the physics score?
95.
95. Chemistry score?
85.
85. So we do comma, then we come to the next student, which is Aquia, right?
Yeah.
And then we can also duplicate this and edit. What is the math score for Akuya?
78.
78.
Yes.
What is the math score for
The physics score 70.
physics is 70?
Yes.
Yes.
And what is the math score for, so what is the chemistry score?
80.
80.
80. So
Yes.
is that the end of the list?
No.
No.
That's with
Is that the
ABBA.
ABBA?
So comma. ABBA. Math score for ABBA.
90.
90.
90, good. But I'm intentionally leaving it at 85 because will you find a way, we'll learn something about how we can do some modifications. What's the physics scores?
85.
85.
85.
Yes.
And what is the chemistry score?
88.
88.
88. Let's leave it like this. Okay, now we can create our dictionary. When we run, it will create our dictionary object called student scores. If you want to confirm it, you can call student scores. Students underscore scores. Yeah, so this is it. You can do all the things we did. You can do students. You can do student scores dot keys. Dot keys. So the keys method to return all the keys in the dictionary. Ama, Kofi, Akuya, Abba. And you can do student scores dot scores. Dot values. The values method dot values. That should also give you all the corresponding values. And you can do student scores dot items. We have actually learned all of these things. We are just revising them. And it gives you all of them as it is. What we can also do is that we have learned them already just for revision. We can use the keys to access values and modify values. For example, when we're doing the ABBA thing, we intentionally left some of the values wrong. So let's now set them right. So when I do student scores, this is an accessor notation. When I use square brackets in this case, it's an accessor notation, which means I'm accessing some portion of that structure, data structure. So if I say the key is ABBA, and ABBA is a string, so you have to pass it in a string notation, which is the quotation marks. So students underscore scores ABBA. This one means that I want to access the value of ABBA, or the elements which connects, the element in the dictionary connects with ABBA. I want to access the value. I want to do something with the ABBA line, something like that. So now when I do this, I am on this, I'm actually around somewhere here. So student scores ABBA. So now this will help me, when I do just this ABBA, it will extract the whole of this. This is the value that corresponds to ABBA. Math 85, physics, blah, blah. When we run this, that's what you will see. Math 85, physics 88, blah, blah, blah. So when I do the same thing again, students, ABBA, then I know when I do this, I'm here. But you see, this is also key value pair. So there's another key thing. Then I do another level of accessing of a key to another square bracket, which is math. Then in this case, I am being specific. I want to extract only the math. When I run this, it will extract the math score, which is 85. So now if the 85 is supposed to be something else, what should it have been? 90, right? Are you with me? Students, are you with me?
Yes, please.
Yes,
It was
please.
supposed to be 90 and we did it 85.
Yes, sir.
Okay, so
Yes, sir.
now I can do this kind of code. Student scores, I have accessed ABBA, I have accessed the math. Then if I say 90, it means I'm setting the math score to 90. And when I run this, okay, let me just call the student score automatically for you to see the new dictionary. Then you can see that ABBA's math score will be changed from the current 85 to 90. So you check ABBA. ABBA's math score is now 90. And it's the same way you can use to do any of those kind of stuff for any of the students. So now, dictionary, in the meantime, is okay. The rest of your job is you ChatGPT to learn a lot about dictionary methods. What can you do with dictionary? What can you change? What calculations can you do? Blah, blah, blah. That learning is yours. You are a student. That is your job. A student's job is learning. So now let's go to converting the dictionary into a data frame. So we learned about the most commonly used way of the data frame constructor, which is there's a function in pandas. It means data frame construction has to do with pandas, and therefore you need to call pandas. We have already imported pandas, so we only need to call pandas PD. Then there's a function. So this is how the structure is like. The bigger package, all functions inside the bigger packages are accessed through the dot notation. So pandas is the bigger one. The function in pandas, if I want it, I just say pandas dot, then the function. So pd dot data frame is just how the programs are arranged in the folder. So I'm inside a bigger folder called pandas, and then inside that bigger folder, there's a subfolder called data frame. So that's the kind of structure, and that's how we do the accessing of these packages and functions. So if I want to convert this dictionary into a data frame, I'll have to store, I'll say df. df is the short notation for data frame, but you can give it a better name to reflect exactly what you're doing. df is generic. So maybe you can do student scores df, something like that. So df equals pd dot, just know the syntax, dot. This is just like speaking anything. If you want to learn to speak Frafra, when they tell you this word means this, you take it as that. So that's how you learn. This is also like Frafra or any other language. When you are creating a data frame, you say pd.data frame. And the data frame needs to be typed like this. It is like a rule. That's how you have to speak it. Yeah, there are rules in every language. So you have to go and probably go and ask the English why, if you have jump as jumped, dance as danced, why doesn't it follow throughout for all of them? Then eat, it's also a verb, so eated. Yeah, but it doesn't work that way. So it's, some of these things are also in programming, but a few of them. So pd.data frame is a function. So open, closing parentheses. Then you can pass the dictionary objects. If you don't have the dictionary object already created, you can create it inside this data frame constructor. For example, I could have said curly braces, just like we were creating the dictionary for the first time. So now I am now going to create the dictionary inside the data frame straight away. So it would have been this, AMA, then you do, it is again a dictionary of math, which has a paired value of, let's say, any value, 40 or 50. So this is the first, sorry, this is the first pair, and then the next pair, sorry, the next pair is physics, which is, let's say, 30, and then oh, chemistry, let's say 20. This is just for illustration, how you will do it straight away without creating the dictionary first. So let's say this is ABBA. And let's just change a few things here. 70, 50, let's say 70. ABBA is a good girl. So now when I run this, it creates this DF. When I do DF, you'll be able to see the data frame, because we pass the dictionary straight away into the data frame function. But in our case where we have kind of moved sequentially, so we have the dictionary already created, it's just a matter of saying df. So let me collapse the whole of this thing. Just a matter of saying df, sorry, df equals pd.data frame into bracket the dictionary object's name. How did we store the dictionary? It was student scores. This is the dictionary. So we can copy this as the name and pass it to this data frame constructor and then call df. So this is it. There is another piece of code that I find you can add here. There's something they call orient. I think it's the orientation or something like that. So it's the orientation of the table. Now you can see that, okay, the students are the columns. So AMA, and then we have the rows are the courses. How about if I want to swap it? So you have this piece of code which is orient. I guess is for orientation. Orient equals index. Basically what it means is that you want to change the orientation and you want the row numbers to be the student, sort of kind of swapping it. So when I run it this way, okay, so Okay, so let me clear this. I will explain why it is behaving this way. Let's clear this. So in a basic form, this is how you convert the dictionary object into a pandas data frame. Once you have it not in this form, now look at this form, this one. Or if you want to look at it from the code itself, this one, and then this one. When you run this one, you get something like this. So this kind of data, the way we see it, and this one, which will be more easy to manipulate. That is why this is a richer data structure, which can help us do so many things. In the meantime, we can extract all MS scores across all the courses and probably sum them. So when we do something like DF, this is an accessor notation, and let's say AMA. What it will do is it will kind of slice, or if you like, it will take MS portion of the table. So let me run it. So this is MS portion of a table. It extracts it in a series data structure. So you see MS portion of the table is math is 85, physics is 88, chemistry is 90. If I want to sum all the scores across the 3 courses, I just need to say dot sum. It's a method, it's a function, so that sum will close with a parenthesis, open and close with it. Then it will tell me, okay, the sum of MS scores across the 3 courses is 265. Pandas is built on top of NumPy. So it inherits most of the numerical power and advantage of NumPy, which means that I can do the average of the scores. So instead of sum, I can do the mean function. So dot mean, and it says 87 point blah, 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 blah. Another thing I can do with this kind of data structure is that I can calculate another column. Maybe you can do a total column, which will try to sum, in this case, how are we going to sum it? It's going to give us the sum of the scores for each course because it's going to sum vertically. When you create a column, the column is a vertical kind of great. So let's see it. When I do df, and when I do this square bracket notation, which is like an accessor notation, what it's going to do is that, okay, it's going to look at the columns heading of the table. If it finds a matching column, it will return the data, portion for that column. If it doesn't find anything, it interprets it as you want to create it. So if what you supply is capable of creating that column, it will create a column. So in this case that we want to create a total column, we will just pass total. That's what we want to do. So it will search for total on the columns headings. If it doesn't find it, then it creates it. Total is equal to df. And another thing is I can use, in this case, I can use the accessor notation. But once the data frame is created, the data frame object, every column of the data frame is an attribute of the data frame. So in this case, the column labeled AMA is an attribute of the DF table. The column named Kofi is an attribute of the DF object. So I can use the dot notation, which is a way of accessing an attribute, to also get the column. So I can do df.ama. In that case, you don't need any kind of string notation, which is the quotation mark. So df.ama plus df dot It doesn't make sense, but I want to tell you exactly why I'm doing that way. Later, I'll show you the proper way to do it. df.coffee plus df.abba. It's not naturally sensible the way I'm doing it, but the logic is that we want to create a total column which sums the rows. So the total column will come somewhere after ABBA, and then it will sum for math, it will sum for physics. That's something that we are doing. When we want to do something like that, this is how you create the code. We are summing the columns to provide the row totals. So when I run this code, it will create a total table, a total column. It will create a total column and sum them. So 85 plus 92 plus 78 plus 90 is this two, blah, blah, blah. We could have created an average or mean column and defined a formula for a mean. And then it will do that. Similarly to how we changed a value in the dictionary, you can also change values through here. So when I do df dot AMA, so now this one will access all the AMA column. So when I run this, this is what you will see. So if I want to, from the AMA column, maybe I want to kind of access so let me say df.ama.math. I'm just kind of experimenting. Yes, so df.ama.math will give you 85, which means that AMA's score for mathematics based on how the data is structured. Anyways, there's another way that you can also construct the same data frame. There's a little bit of a new way of doing it. In fact, I just recently saw it. You can say, so let me call it df1 equals pd dot data frame dot from underscore date. What this is English. It's saying that, okay, we know pd.dataframe creates, it's a data frame constructor. So it creates a data frame. But when I do dot from date, it basically means that, okay, I have a dictionary object from which I actually want to create this data frame. Then you pass the object's name. But I think it's a bit longer because this is shorter. But this is another way of doing it. Maybe it has an advantage. So when I pass the object name, which is students course, yes, that's how we did it. It's supposed to create it as a data frame. So when I call df1, yes. Now I think, let me do the one I was trying to do, and then I had that challenge. Okay, so this piece of code, so maybe this will be the key advantage of using this kind of constructor, the data frame dot from date, is that you can pass this orientation and then you change the index, you swap the index. So now when I did this data frame dot from date, I passed the dictionary object. And this piece of code, orient equals index, which simply means change the orientation by swapping the index. This is how I interpret it anyway. You will see that now the basic one was the students are the column headings. Now the courses are the column headings. And then we have the student as the rows. Usually for data like this is how we want it to be. The students are the rows and the subjects are the column headings. And then you can do all the manipulations. The last bit of manipulation we want to look at, for the purposes of time, not for your learning and the exam anyway, you have to learn more, is that we can perform some visualizations on this. We can do, in this case now, we can create the total. We can do df1 total equals, now we are going to sum the total for each student, which is the sum of the scores across the subjects. This is more reasonable. That's why I said the other one is just for the logic of how things work. I think this one will make more sense to you. So now I will do df. df has an attribute, which is the column called math. So df.math plus, plus it's df1, please. If you forget about this, our object name is df1. If you say df, it will go and use the df table. So df1 dot physics, make sure you type it correctly, plus df1 dot chemistry. So that's the formula. Sum for each student, sum the scores, sum the scores for the courses. So this is how you do it. This is the logic. And this is the usual way we normally do this stuff. It's not any technical thing. And the maths behind it is basic mathematics, summing, adding things up. So it will create this total column, and then it will calculate the total column as we have specified in the formula. So I'm going to call df1 as part of this code so you can see that calculation. So you see total. So for AMA, you can see it like that. So now let me plot. I can say df dot total. Data frame has a plotting method. It actually borrows these plotting methods from the matplotlib library. We will not be able to talk about it. I'm talking about it in person. You can just be curious and read things about it, reading about it. In the meantime, don't worry about really understanding it. Next semester, when we are doing management accounting, we will be implementing most of the stuff in management accounting through Python, and we'll get the opportunity of exploiting these plotting libraries like matplotlib and others. So df.total.plot will actually do a line plot. So if you say the plot, you see the plot is a function. When it is being applied to an object, in this case, that's why we are using the dot. It means it is inherited, it is embedded in that object. The object inherits it automatically because of the object's nature. In that case, we do it as dots. So the dot means it's part of it. And if it is part of it as a function which is built as part of the object is called a method. That's the difference between a function and a method. So the parenthesis here means it can take some arguments, but it can also be made to behave by default without any arguments. It does some basic stuff. So this plot method without any argument will do a line plot. So you don't need to specify kind equals line. We can do kind equals line. The line needs to be passed as a string. Kind equals line. We can do kind equals another chart, which suits this kind of data structure. You can change the kind of plots you want to do. But if you don't specify anything, the default is kind. So let's see. Okay, so this is what it's telling you. It's saying, okay, this is the visualization of the total scores. It starts from this number, and it's like it rises at this point, and then it drops. Vim. Okay, so this is the nature. This is the nature of it. You can do similarly for all of the other objects. For example, if I do df dot, I want to see the behavior of the scores in mathematics. So df dot math dot plot. Okay, so this math is for df1. So please I think df1, let me see. Okay, so I have two objects, df and df1. Actually, we are doing this on df1, so we have to be cautious. So df1.math.plot, I'm using this dot notation, and there's a way you use this dot notation if your object naming doesn't have spaces. So sometimes, to be safe, whether the thing has spaces or not, you can use the square brackets. In that case, you pass the math here as a string math, and it will do the same thing. You can use ChatGPT to learn about when you use this and that to solidify your understanding. Yeah, so basically, this is where I can take you. Time is fast spent, it's almost 11. So you can go through this and extend your learning around this, and you should be fine in the exam. If there is time, if there is no time, you have to deal with the database yourself. There are a lot of content on the web. If I get some good ones, I'll share with you. But if you care about a session where we explain things together, you can also, that one is up to you to decide. If you decide so, then you let me know the time, and maybe I'll make the time and take you through that. Otherwise, we can find some videos and do it ourselves. Is that okay?
All right, sir.
Okay, so if there are no questions, this is where we end the session. Thank you very
So
much for
I want to ask you a question. Hello. Sir.
Yes, please speak out.
Sir, about the plot. Is there any way that you can plot all the different lines on the same plot?
Yes, so just go and use ChatGPT to ask that question to ChatGPT. You can plot all of them on the same chart using Matplotlib. Like I told you, the content we're supposed to consume for the semester, we can do all of this extensive stuff. So next semester, we will extend it through management accounting. So you get the opportunity to see all of these things. Is that okay? But before that, you can explore. I mean, your learning should be driven by your own curiosity than what a teacher wants to teach you. Okay, if there are no further questions, then this is where we end the session. Thank you very much.
Welcome, sir.
You are welcome, sir.